Hello everyone. In this video, we are going to discuss about equivalence of NFA and DFA. NFA and DFA are equal in power, though DFA has more number of transitions than NFA. And NFA has very simple to construct than DFA. There are two steps. Um, there are two steps. First one, conversion of DFA to NFA. Second one, conversion of NFA to DFA. Here we can say that every DFA has an NFA. So there is no need to prove that and first step, that is DFA to NFA. The reverse is not possible for every NFA is not an DFA, because NFA can have many number of transitions from each state for the given input symbols, but DFA can have only one next state, that is DFA has only one move from a given state on a given input symbol. So we cannot say every NFA is an DFA, but there is an equivalent DFA for each NFA. There is an DFA. So we have to convert NFA into DFA using subset construction method. In this video, we are going to convert NFA to DFA using subset construction method. So now we accept, that is we will discuss about one example for this. Here I have to take one NFA diagram. Q0, Q1, Q2. Q0 is the starting state. Q2 is the final state. So I have to put double circle. 0, 1. So in this NFA which accept all strings ending with 1 1. By this NFA we are going to construct NFA to DFA using subset construction method. Here both the NFA and DFA having 5 tuples. That is Q, epsilon, transition, Q0 and F. Q is a number of state, epsilon is an input symbols, this is a transition symbol, Q0 is a starting state, F is a final state. NFA having n states. You have to take NFA as an n state. Then we have to convert the DFA means 2 to the power of n states. NFA is an n number of state means convert DFA to 2 to the power of n state. Here in this example there are 3 states, that is Q equivalent to number of states, Q0, Q1, Q2. Epsilon equivalent to input symbols. Input symbols means what are all the transitions used in this diagram? 0, 1. Transition we have to convert, we have to construct. Q0 is the starting state. F is the final state. F is the final state. Here we can use the subset construction method for a given NFA diagram. Here subset, in this example n equivalent to 3 states. N equal to 3 state means DFA equal to 2 to the power of n. Therefore, 2 to the power of 3 equivalent to 8 states. So now you have to construct 8 state of the subset construction method. So therefore, subset equivalent to, first we can use a state as pi. Pi means no state, that is no transition will be occurred in a DFA. And then how many number of states is there? 3 states. So we can use separately single Q0, Q1, Q2. Then what are all the possibilities we can use? What are all the possibilities we have to construct in this given 3 states? We have to make some number of possibilities. Q0, Q1, Q2, Q0, Q1, Q0, Q1, Q0, Q2, Q1, Q2, the last one Q0, Q1, Q2, 3 states. So this is also called a subset of the number of possible states. And then we have to construct the transition table. Transition table for DFA. Transition table for DFA. So in that 8 states, 1, 2, 3, 4, 5, 6, 7, 8. So 8 states we have to make it. Here a transition table, we know that how to draw a transition table. Number of states, inputs. So inputs alpha will be equivalent to 0, 1. 0, 1 is an input symbols. So 0, 1. So we have to make it pi. Pi is the first state. Next Q0, Q1, Q2, Q0, Q1, Q0, Q2, Q0, Q2, Q1, Q2, Q0, Q1, Q2. So 1, 2, 3, 4, 5, 6, 7, 8. 8 states we have to use in this transition diagram. Here Q0 is the starting state, that is initial state or starting state. And then here in this diagram Q2 is the final state. So Q2 final state, we have to identify the Q2 state. This is the Q2 state. So we have to mention star Q0, Q2. This is also used in final state. This is also used in final state. This is also used in final state. So we have to easily identify. We have to make it the starting state as arrow. We have to put the arrow symbol, and final state I have to make it star symbol. And then pi means no transition will be occurred. Okay, next one. Q0, the state Q0, 0. In the state Q0, 0 means 0 is the input symbol when the transition will be occurred to Q0, 0. In this diagram Q0, 0 means Q0 is the state, 0 is the input symbol. So the transition will be occurred to Q0 also. So Q0. Q0, 1 means the input symbol 1, the transition will be occurred to Q0, 1 mean 1 will be occurred in Q0 also, and also 1 the transition 1 will be occurred to Q1. So therefore Q0, Q1. Next Q1, 0. Q1, 0 means no transition. So pi. Q1, 1 means Q1, 1 means Q2. Next Q2 comma 0. Q2, so no transition, so pi. Q2 comma 1, no transition, so we have to put pi. And then Q0 Q1, Q0 Q1. Q0 Q1 means Q0 Q1 means Q0 union Q1. Q0 union Q. Here we have to union. Q0 union Q1. Q0 means Q0. Next Q0 Q1 comma 1 means Q0 union Q1. So Q0 Q1 Q2. Q0 Q1 Q2. Next Q0 comma Q2. Q0 Q2 equivalent to Q0 union Q2. So therefore this is Q0, this is Q2. So Q0 Q2 comma 0 means this union this one. So Q0 only occurred. This is Q0 Q1 because Q2 is an null state. Q1 Q2. Q1 Q2 equivalent to Q1 union Q2. So therefore Q1 union Q2. This is null, this is also null. So we have to put null. And then Q1 union Q2. Q1 union Q2, only Q2 state is there. So we have to put Q2. The last one Q0 Q1 Q2. Q0 Q1 Q2 equivalent to Q0 union Q1 union Q2. So Q0 Q1 Q2. So union of these three states. So Q0 only is there. This union Q0 Q1 Q2. This is the transition table of DFA. And then finally we have to convert transition diagram for DFA. Transition diagram. Transition diagram for DFA. This is a transition diagram. So first starting, so how to make this transition diagram means we have to make it in the accessible state. First we have to identify the accessible state. Accessible state means now we have to consider as only accessible state. Here if NFA has n number of states, NFA has n number of states, but DFA has 2 to the power of n states. But not all states are accessible. Here 2 to the power of n state. Here in this example 8 states are there, but we cannot use these all 8 states. Only we have to use in the accessible state. So we need to consider only the accessible state. So Q0 is the starting state. So I have to put Q0. Here Q0 we have to consider from Q0 what are the new states are introduced. Q0 comma 0 means Q0. So Q0 is already used. Q0 comma 1 means Q0 comma Q1. So this is the new state. Q0 comma Q1 means directly we have to jump to Q0 comma Q1, this state. First initial state we have to select it. In that initial state, what are all the new states are introduced. Q0 comma 0 means Q0 is already there. Q0 comma 1 means Q0 comma Q1. Q0 comma Q1 is the new state. So we have to jump it up. Q0 Q1 comma 0 means Q0. Q0 is already there. Q0 Q1 comma 1 means Q0 Q1 Q2. This is the new state. So we have to Q0 Q1 Q2. This is the new introduced state. Here in the states having Q0 only. Q0 already is there. Q0 Q1 Q1 is the this state. So we have to select the accessible state only 3 states. Q0 Q0, Q1, Q0, Q1, Q2. So Q0 is the initial state. Then the accessible state is Q0, Q1. Another accessible state is Q0, Q1, Q2. So I have to make it these states. Here Q0 is the starting state. Q0 is the starting state. Q0, Q0 comma 0 means Q0. So you have to put 0. Q0 comma 1 means the transition goes to Q0, Q1. Then we have to check Q0, Q1 comma 0 means what? Q0. So Q0, Q1 comma 0 means Q0. The transition go to Q0. Q0, Q1 comma 1 means Q0, Q1, Q2. So 1. Then Q0, Q1, Q2 comma 0 means Q0. The transition go to Q0. And then Q0, Q1, Q2 comma 1 means Q0, Q1, Q2. So 1. So here this is Q0 starting state. Start, you have to mention that Q0, Q1, Q0, Q1, Q2. Here Q2 is the final state. So we have to make it double circle. We have to make it in the double circle. So this is the final transition diagram for DFA. Thank you.